Hello everyone. In this video I am going to begin with another group of elements of the PBlock, the group 14 elements, that is the carbon family. Okay, so the topic is the carbon family. These are the group 14 elements. Okay. The elements which belong to this group are as follows: carbon, silicon, germanium, tin and lead. Okay. These are the elements which are in the carbon family. Okay. Now, let me tell you a brief introduction of each of these elements. Okay. Now, carbon, there are two stable isotopes of carbon, the C12 and C13. These are the two stable isotopes. Carbon also has a radioactive isotope called C14, which you may be familiar of. C14, it is used for carbon dating. Okay? And it is radioactive in nature. Okay? Now this is the important feature of C14, that it is radioactive and so it is used for carbon dating. Okay. Now let's move on to the other elements, silicon and germanium. Okay. Their ultra pure form, okay, their ultra pure form is used for making, you might very well know, semiconductor devices and transistors. Okay, their ultra pure form is used to make transistors and semiconductor devices. Okay. Now, tin and lead. Okay. Tin, you might have seen the asbestos on the roof. Some people put the asbestos of tin on the roof. This is one of the use of tin, and tin also forms a constituent element in many of the compounds. Okay, and lead, it is used for making paints. There are lead paints which are manufactured. Okay, so these are the brief introduction about the elements. Now let's move on to the position of the elements in the periodic table. Okay, so the position of the elements is, first there is hydrogen, then there is helium. Okay, beneath hydrogen there is lithium, then there is beryllium, then there is boron, and then there is carbon, nitrogen, oxygen, fluorine and neon. Okay, so this is 1, this is 2, this is 3, this is 4, 5, 6, 7, 8, 9 and 10. So here there is carbon, and beneath that lies the carbon family. Okay, carbon, silicon, germanium, tin and lead. Okay, this entire group is the carbon family. This is the carbon family. Okay. Now, what would be the electronic configuration of all these elements? Let's see that. Okay. The electronic configurations are as follows. This is 1s1, this is 1s2, this is 2s1, this is 2s2, this is 2p1 and this is 2p2. Okay. So for carbon, the electronic configuration is 2s2, 2p2. For silicon and for all the others, the electronic configuration would be what? The electronic configuration would be what? ns2 np2. Okay, this n over here is for 2s2 and 2p2. Okay, so the general electronic configuration for all the elements of this family is ns2 np2. Okay, now Let's see some properties of these elements. The first property which you would see is the covalent radius. Okay, we are gonna see how the covalent radius varies in this family. Okay, now the order for the covalent radius is as follows: carbon is less than silicon, is less than germanium, is less than tin, is less than lead. Now, as you must have studied in the periodic table that as we move down the group, okay, down the group, covalent radius increases. Okay, and this is what we see over here, that down the group covalent radius increases. The values for the covalent radius in this case are: for carbon it is 77, for silicon it is 118, for germanium it is 122. Okay, it is 122. For tin it is 140, and for lead it is 146. These are all in picometers. Okay, these are the values. Okay, now you might see that the increase in radius from silicon to germanium and the increase from radius from tin to lead is very less. This increase is very less. Okay, let me also bring to your notice that the order for the group 13 elements. For group 13 elements, let me remind you that the order was what? It was boron is less than aluminium, which is greater than gallium, which is less than indium, is less than thallium. And the values were 85, 143, 135, 167 and 170, again in picometers. Okay, so these were the values. Now, like I told you also in group 13 elements, the reason for this discrepancy lies in the fact that the D and F orbitals offer poor shading effect. Okay, so the reason is poor shading effect of D and F electrons. Okay, so this is the primary reason of this discrepancy being observed. Okay, so what happens is that since the D and F electrons offer poor shading, therefore the atomic radius increases. The atomic size decreases. Okay, so you can observe it in this manner, that if this is the nucleus over here, okay, and these are the orbitals. Okay, now since the D and F electrons present over here, okay, the D and F electrons present over here, they offer poor shading effect to these outermost electrons. Okay, so what happens is that this nucleus, the nucleus present over here, it pulls these electrons towards themselves, toward the nucleus. Okay, therefore the covalent radius decreases. Okay, this is the primary reason for decreasing this discrepancy. Okay, in general, for all the PBlock elements, okay, in general, you find that only discrepancy or only exception is in group 13. Okay, that is this exception, that for gallium the radius is less than aluminium. Why? For in this case, you can see that the increase, although there is an increase, but the increase is guess. But increase would definitely be there. Okay? So, only exception is in group 13. Okay? For the rest, okay, radius increases, although the increase may be yes. Okay, and the reason is again the poor shading effect of D and F orbitals. Okay, now let's move on to another property, that is the ionization enthalpy. Okay, or ionization energy. Okay, now the order for ionization energy is as follows. Okay, it is carbon greater than silicon, is greater than germanium, is greater than tin, is less than lead, and the values are, for carbon it is 1086. This is delta ionization 1 for removing 1 electrons. Okay, for silicon it is 786, for germanium it is 761, for tin it is 708, and for lead it is 715. This is in kilojoule per mole. Okay, this is the value. So you can see that in case of, although what does the general trend say? The general trend say that down the group ionization enthalpy should decreases. But here we find an exception. In this case there is an exception. Okay. Now, let me also bring it to you that the ionization energy of group 14 elements is greater than ionization energy of group 13 elements. Okay, and you know that this is this is how it happens. The reason for this is increase in nuclear charge. This you must have studied in PBlock. Okay, that when we move in the period, across the period, the ionization energy increases. Okay, now, so what can we say in general? That, let me also bring it to you that for group 13, the delta ionization 1 was as follows. For the order was boron is greater than aluminium, is less than gallium, is greater than indium, is less than thallium. Okay, so this was the order. The ionization enthalpies must have decreased, but this discrepancy was observed, and the values were 801, 577, 579. Sorry. This is 579, 558 and 589. This is again in kilojoule per mole. Okay, so this was the order in this case. So the reason for this is, now the reason for this again would be what? The reason is the same. This is, that is, poor shading effect of D and F electrons. D and F electrons. So what do the D and F electrons do? Since they offer poor shading, which we saw over here, okay, since they offer poor shading over here, so the covalent radius decreases, and since the covalent radius decreases, the energy required to dislodge these electrons, these outermost electrons, would be more, and therefore such discrepancy is observed. Okay, and in general we can say that in general the ionization energy decreases down the group. Okay, but you need to remember the above exceptions. Okay, now let's move on to another property, that is electronegativity. And let's see the order. Okay, now first of all, group 14 elements. Okay, can you tell me that group 14 elements will be more electronegative or less electronegative than group 13 elements? Most of you would have guessed group 14 is more electronegative than group 13 elements. Okay, again you must have read this in periodic table that moving across the period the electronegativity increases. Okay, and the reason again being the increase in the nuclear charge. Okay, now in the group, okay, in the group what happens? In group, when we move down, okay, moving down the group, the electronegativity should, what it would be? The electronegativity should increase or decrease? The electronegativity should decrease. Okay, this should happen, but actually the electronegativity remains almost the same. Okay, so the electronegativity should decrease, but it is found that the electronegativity remains almost the same. Okay, the order for electronegativity is as follows: carbon greater than silicon is equal to germanium is equal to tin is less than lead. The values are, for carbon it is 2.5, for all these it is 1.8, and for tin it is 1.9. This is the value, okay, of electronegativity. And the reason for this discrepancy is, again, the reason for this discrepancy is due to, the reason is due to the poor shading of, due to the size factor and the shading effect. Shading effect of D and F orbiters. Okay, so this is the primary reason. Okay, now let me tell you the physical properties of group 14 elements. Okay. Now, physical properties, carbon and silicon. Okay, they are non-metals. Carbon and silicon are non-metals. Germanium, on the other hand, is metalloid. Okay, tin and lead. Okay, tin and lead are soft metals. Okay, so this is the physical property of group 14 elements. Okay, so in this video we saw the introduction to the group 14 elements, okay, and their uses. We saw the electronic configuration, their covalent radius and their order, and compared them with the group 13 elements, and we saw the reason for it. We also generalized and noted the few exceptions, and we saw the ionization enthalpy and their order, and again we noted the reason for the discrepancy, and we saw the electronegativity. Okay, this is electronegativity. We saw the electronegativity and their order. Okay, and we also saw the reason and the physical properties. In the next video, I will tell you the chemical properties of the group 14 elements. That's all.